reinforcement learning application in financial training and investment workshop. This is one of our workshops in the series of the workshops we started on AI application in finance. My name is Abubakar Sani Ali, and I will be the one who will guide you through this workshop. So as a disclaimer, I would like to mention that what we're going to discuss today is solely for educational purposes and not a financial advice. We highly recommend that if you need a financial advice, you should go and seek an expert. Agenda of today. So first of all, I will start with an introduction. Then I will discuss an overview of machine learning, after which I will discuss neural networks. From neural networks, I will move on to reinforcement learning. Then we'll see how we can develop trading strategy that uses AI. After which we will build a trading bot, okay, based on a framework. You will see me build it live, and after which we will have an open interactive Q&A session. So once again, I welcome you to this exciting workshop. And as I said, my name is Abubakar Sani Ali. I have a PhD degree in electrical and computer engineering from Khalifa University in the UAE. Before then, I did my MSc in communications and signal processing from University of Leeds in the UK. My bachelor's degree major was electrical engineering. The host institution is called Asatora Services, and in Asatora Services, we provide 3 different types of services. One, we provide consulting services in AI, Internet of Things, and cyber security. Not only that, we provide training and workshops as well as research and development in these 3 fields. The goals of our workshop today is to first of all understand the basics of machine learning and how it is applied in trading and investing. After this, we will look at some case study that has been used, in which AI has been used in the context of trading and investing. Lastly, we will see how to build a trading bot based on a reinforcement learning system, which is the title of our workshop today. So basics of machine learning. So I will start, and if you have any question, please do not hesitate to ask. All right, you can raise your hand and I will be able to see and I will respond immediately. Not only that, if you have any question, you can also send it in the chat and I will also be able to respond to you once I see this. All right. So machine learning. What is machine learning? Well, we have been hearing about AI, artificial intelligence. Then suddenly we started to hear about machine learning. So the question is, how are these two related? Is AI the same thing as machine learning or not? So AI is like the umbrella, okay? And the machine learning is just a subset of that umbrella. So it's part of AI. And in machine learning, when we talk about it in relation to AI, we are talking about those systems that learn from experience. So they require some historical data, which they will take a look at. And based on this data, they learn. And by doing that, they avoid, or we do not need to explicitly program them. Okay, because they can learn from data. We do not have to write instructions explicitly to say when this happens, this should be what you will do. And in terms of applications, these are some of the applications which I'm sure you have come across. For example, email filtering. You can see if you open your mailbox. You have inbox folder, you have spam folder, you have promotions folder, social folder. All this kind of filtering system mostly is powered by AI, because you do not have some person who sits there trying to say, okay, this message or this email should go to inbox, this one should go to, junk and stuff like that. Speech recognition systems like Siri, Cortana, you know, not only these two guys, you also have Alexa and so on, or Google Voice. All these are powered by AI or machine learning. Predictive analytics, this is the types of systems that try to predict what is going to happen, what is a particular object. Okay, so these are some of the applications you are aware of. Like what we're going to do today, we are trying to make prediction into whether to buy or sell, okay, or sell a particular asset. And the tasks of machine learning can be classified into three. You have supervised learning, unsupervised learning, and reinforcement learning. Supervised learning comes in two shapes. You have the regression and the classification. Unsupervised learning comes in multiple shapes. Okay, and in the case of supervised learning, this is a process whereby the learning occurs with a teacher or with a supervisor. So this is like, for example, you are trying to learn how to predict stock price, and I sit with you and I tell you, okay, once this happens, this is going to be the result. Okay. So for example, let's take one example of RSI. So if we say, okay, once on so day, RSI value was this, and this is the closing price at the end of the day. So we have the day, what day it was, we have the RSI value, and based on these two values, we want to predict what is going to be the output, or what is going to be the cost at the end of the day. How much will that price close? Okay. So this is supervised learning. So we have this data, for example, made available to us. And as I say, it comes in two shapes. You have the regression and you have the classification. For the regression here, what you're trying to predict is a continuous value. Okay. You have a continuous value. For example, you want to predict house price. You want to predict stock price. You want to predict age of people. So maybe from their face, you want to tell how old is this person. Okay, you want to predict this. You want to predict how heavy is somebody, in kg, for example. Classification, on the other hand, is all about categorization. Okay, let's say we have students. You have good students, bad students. All right, so this is categories. You have genders. You have different categories of gender. All right. You have animals. Each animal is a certain category. Okay, you have humans, you have cats, you have dogs. Unsupervised learning, on the other hand, does not require a teacher. There is no teacher in the process. You only have the sample data. By not having a teacher, we mean there is no result. When we have the data, for example, in classification, you can say, I have images of cats and dogs, and I tell a kid that this is a cat, this is a dog, this is a cat, this is a dog. By doing this, the kid is able to learn. But for the case of unsupervised learning, I'll just give him all images, give it to him. I will not distinguish cat and dog for him. I will allow him to figure out which ones belong to a particular group and which other ones belong to a particular group. Of course, we might not have an idea how these connect. Reinforcement learning, however, is different from the previous two. Both supervised learning and unsupervised learning require data. Reinforcement learning does not require historical data. All that is needed is the environment or the system, and you put the agent and it learns by trial and error. Like as I said, you are trying to learn how to ride a bicycle, for example, or how to trade in the financial market, and you just go with your money in the financial market and you buy and then you sell. Okay. So when this happens, where you are buying and selling in the financial market without historical data, this is called reinforcement learning. You are learning by trial and error, and this happens. For example, you open a paper trading account with any broker, and they give you, let's say, $10,000 or $20,000 to open your account with. Then you go there and you start to trade without any historical information. Nobody is there to tell you how to trade. Nobody is teaching you. You are just there trying things by trial and error. So that is reinforcement learning. So machine learning has been used in the context of trading and investing uh, for a while. For example, why they even use it? One is it enhances predictive accuracy. So let's say I have some idea, okay, of how to trade in the market or how to invest. So I will come, do my mathematics, come up with an idea of what is going to be the price of a certain asset. If I know this price, for example, and then I have a system which is AI that was trained from historical data. And this historical data was obtained from observing how Warren Buffett makes trades. Okay, so we know, for example, on so date, Warren Buffett purchased a particular stock and he sold it after so years at a particular price. Okay, so these data were collected for all the trades that were carried by Warren Buffett during his lifetime, and we use this to train a model so that the model can try to mimic and understand how Warren Buffett makes trades or buys and invests. So I have this system that has been trained based on Warren Buffett's history, and then I also have my own system which I developed. Okay, so I came with my system, make predictions, and I know the price after maybe 1 year, and I use that system which tries to mimic Warren Buffett, and it also gave me almost similar prediction. So this improves my confidence in my own decision making, and that is the data-driven decision making approach, where you have this particular system that learn from historical data and is helping you. Okay, so this is one of the things we are talking about. So they have been using it either for price prediction, as I indicated, to predict how much a certain element is going to be or asset is going to be in a particular time in the future, or how to manage the risk. So if you have, let's say, $10,000 in your account, which percentage are you going to invest? If you spot a trading opportunity, are you going to put everything you have, or are you going to just put in a little amount or a certain percentage? So determining this percentage also could be allowed to be handled by the AI. You may be doing the prediction where you predict what price the asset is going to reach, and then the AI is going to manage your risk. It will tell you, okay, this looks good. Maybe let's go in 10% of our capital and buy this asset. Okay. And as I said, this has been in news. For example, the big guys in Wall Street have used AI, well, such as these guys are all big names. Okay, Renaissance Technologies, BlackRock, Citadel, Charles Schwab, JP Morgan, all of these four or five of these and others, these are big guys in Wall Street, and they have been using AI systems, okay, to enhance their trading performance. So going deep, as I said, as I move from one section to another, I will be giving the chance for people to ask questions. And if you have any question, you can just send it in the chat, or you can raise up your hand and we will allow you to speak up. Okay. All right. So reinforcing neural networks. Okay. So neural networks, the inspiration behind neural networks originated from how our brains work. So scientists have been studying how brains work. And what did they do? They said, okay, since our brains are very good at figuring out patterns, okay, why don't we come up with a mathematical system that tries to learn just the way the human brains learn? And that's where neural network came to life. Neurons are the cells in the brain. Okay. For example, in a single cell of a single brain cell, you have what we call the dendrites, you have the nucleus, you have the axon, and you have the botons. The dendrites, these are the elements that receive signals from other neurons. Okay. Then the nucleus is going to determine, once it receives these signals, is it going to fire, and send that signal across, or is it going to neglect and dump that signal? All right. If it decides to fire, then it is going to fire this signal via the axon, and then the buttons are going to be connected to all other networks so that the right network that is supposed to do the job is going to be activated. Okay. So this is how our brain cells work in a nutshell, for example. And based on this, we try to see how we can mimic these systems for our algorithms. These are the motivations. First of all, humans, we are incredible pattern recognition machines. A human being, even a young kid, is able to recognize good things from bad things. For example, when you see a small kid, okay, playing, and then suddenly an ice cream truck came and parked. Okay, after testing ice cream maybe once, the moment that kid sees an ice cream park, he has already, you know, tried to associate ice cream with nice things, with a good feeling. So the kid will run towards the ice cream seller to try to buy ice cream or to get ice cream. Similarly, when the kid sees something that is scary, for example, a spider, tries to run away from it. So this kind of pattern recognition system is something that we try to mimic. And in order to do that, the mathematicians come up with a simple model. Okay. They said, okay, let's look at this brain set, only one of it. Can we model it mathematically? And if so, how? So what did they do? They come up with something they call perceptron. Just like a neuron, you can see RON. So perceptron, neuron, anyways. So in perceptron, they also have the dendrites, for example, which serve as the inputs of the perceptrons. Okay, and then you have the nucleus, and this is the part that carries out the operations. Okay, and then the output. Okay, and this is like the axon, and the outputs, these are the botons. Okay, so what happens is in this perceptron, the inputs x1, x2 up to xn are what we call the features. These are the independent variable or features, or we call them characteristics. Okay, meaning these are the things that the output is going to depend on. The output is the dependent variable. So if, for example, I'm trying to predict house price, I could come up with so many things that will determine how much a house should cost. What is the value of a particular house? Is this house near a highway? Okay. What is the size of the house? How old was the house built? All this information will help us to determine the right price of the house. Okay, so these are the inputs. These are the independent variables. And the W's you see here, we call them the weights. So just like I was saying, in the case of house price prediction, you want to predict houses. Not all of these features, they are not all of the same equal significance. Maybe size of the house contributes most to the value of the house at the end of the day. No. Maybe, let's say, crime rate of the neighborhood contributes most, okay, to the value of the house. So now if I know what variable contributes most, I can be able to allocate a higher weight to that particular variable, and then reduce the weight value from the other variables that are not as effective and significant in determining the output. The nucleus here will do what? Will carry out a summation function. So it will do like a multiplication here, x1 times w1 plus x2 times w2 plus x3 times w3. So it keeps doing that and it gets a value, a single value. This value could come in huge ranges, for example, all the way from minus infinity up to infinity. All this is the domain of the sum between the w1, x1, and so on. So to avoid this issue, we introduce something we call activation function so that we will be able to constrain our output to be maybe, for example, between 0 and 1. So if the worst case scenario, okay, of let's say we are trying to figure out the value of a house, maybe we can say if the house is, important, we can maybe get some of these multiplications, we sum them up, and then we try to compress everything to be between 0 and 1. Okay, so if this value that is obtained is greater than 0.5, you might say, okay, it is high time for the neuron to fire or to send signal forward. If the value is less than 0.5, then signal should not send anything forward. Okay, so this is how this thing works. All right, so, and this is what I was talking about, the activation function. I also talked about, for example, multi-layer neural networks. So what are these? Okay, so we talked about perceptron. This is one single cell of the brain or of the neuron. Okay, of the neuron, one single neuron. What happens now if we have many neurons? Okay, so then we have neurons, right? For example, here we have around 5 of them. Okay, so we have neurons here, here, okay, and there. So now that we have these neurons and they are all connected, okay, different connections. So you have a connection of neurons or neural networks. Okay, that's where the name neural networks come into play. Just like the brain cells are connected all around, same thing with these neural networks. Layer approach is the process where we have the input at the starting, followed by some hidden layers which we don't know. Like, that's why they are called hidden layer. They are hidden between the input and the output. So for anybody who comes to this system, all he knows is what? These are the values you input, and these are the values you get as the output. Okay, so what happens in between these two is hidden, and normally it can come from one layer. You can have multiple of them, you can have multiple layers between the input and the output. Okay, we can have another neurons here, for example, so that we have two hidden layers. You can have another one, for example, and each one might have its own different number of neurons. So each layer might have, let's say, its own specific number of neurons. So sometimes we used to do, architectures like this, where here we put small number of neurons, here we put a more moderate, and then here we put a larger number of neurons. Okay, so depending on what you're trying to solve, this is where the multi-layered approach comes into play. So the last concept in neural networks I would like to discuss is called backpropagation algorithm. So as I mentioned earlier, the supervised learning approach involves having a teacher who tells a student, okay, gives a student examples and gives him the solution of those examples. Okay, so this student will try to learn the pattern in the example so that it will be able to obtain similar value. So when during learning process, how do we want to be able to train the student? We will normally be giving him quizzes, assignments, homeworks, right, and tests. This is exactly what we are doing here as well. So you provide some of the examples, you give him the output, and you tell him, okay, go and make your own prediction. So it will go and do its own prediction. Initially, the prediction will be terrible, will be so bad. It will be maybe way off. Okay, so it will take its prediction back to the supervisor and tells, okay, teacher, when I make my prediction based on the example you gave me, this was the value I got. Is this value good enough? The teacher will say, no, 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 this is not good enough. Go and try it again and try to maybe reduce this or reduce that or reduce that. Okay? So this same process happens in neural networks too. They will make prediction, then you propagate, the prediction back, you know, to the input to see how far or how good their previous prediction was. All right. So this is a little bit of an introduction with the relation to neural networks. I'm now going to go into reinforcement learning. Okay. So what is reinforcement learning? But before I go, I will also ask if there is any question, please go ahead and ask before I start with reinforcement learning. Okay, so I assume no question. All right, so reinforcement learning, unlike supervised and unsupervised learning, does not require data. No requirement of what? Historical data. All that it needs is to have a situation, then it will take a decision. If the decision it took is good, it will get a good reward. If the decision it takes is bad, it will get a negative or bad reward. Okay? So this is how it lands. So for example, you have a trading bot that is trying to trade in the financial market, and it went to the market, it made a purchase, and the purchase turns out to be profitable purchase. The trading bot is very happy. It brings back its feedback, all right. But if you have, for example, a situation where this agent makes a decision in the financial market and blows up the account, all money lost. Okay, so this is a penalty. He loses the money, he is not happy. All right, so this is how reinforcement learning works, and it has been used in different types of games. For example, chess, ping pong, and also animal. The case of so train our brains to get the appropriate outcome is a plus. Yes, yes, it is. That's how reinforcement learning works. To get the appropriate outcome. Keep doing that by trial and error until when you figure out, okay, so this is the pattern of getting good outcome. All right. So the deep reinforcement learning is one of the techniques. Just like neural network is one of the techniques of machine learning. Okay, the machine learning field is very big, very wide, so many different algorithms. Neural network is just one of those hundreds of thousands of algorithms out there. So under reinforcement learning, you have different types of algorithms and techniques. Okay, deep reinforcement learning is one of those, and it is what I would say is the intersection between reinforcement learning and deep learning. So when you put these two together, deep neural networks plus plus reinforcement learning, okay, you get deep reinforcement learning. So deep neural networks plus reinforcement learning will give you deep reinforcement learning. Okay, so this is what this type is, what we call the deep reinforcement learning. Okay, so in the context of deep reinforcement learning, what we are saying, okay, we will see how it works. Reinforcement learning in general comes with these elements. It will have the agent, it will have the environment. The agent is interacting with the environment. So there has to be an interaction between the agent and the environment. So you deploy the agent inside the environment. In this case, our environment is the lady holding the stick and the agent is the dog. Okay. So when the environment, changes its situation, now the situation of the environment is to hold the stick. Okay. This is the current situation. Maybe the next situation, it will be the environment will throw the stick. Okay, it will throw this stick. So what happens now? We want the agent to observe this change of situation or status of the environment and make a decision. So once the stick is thrown, the agent, which is the dog, has two options: either to fetch, right, or to stay. If the agent fetches the stick, the environment will reward this agent. It will give it a treat, okay? And he will be happy. I am rewarded because I did the right, I made the right decision. But if the agent stays and the environment has thrown the stick, the environment might scold the agent. So it is getting penalty, okay? It will be penalized. So by doing this, throwing, following, and this, the dog tries to figure out, okay, if I want to be given treats, I should always follow and fetch. Okay, always follow and fetch. That is, by doing this, I will be getting rewarded. And this process is, what we call a policy. So our objective is to train the agent to be able to do the right thing, follow and fetch after throw. Okay. So whenever the environment throws the stick, the agent wants to follow and and fetch. Okay. So this is how these things are connected. Okay, you have the agent and it's interacting with the environment. This is the agent, it's interacting with the environment, and the environment will give some observations, which is ST. Okay, in this case is the throwing of the stick, and based on that the agent will take an action AT. Okay, and then once the environment is happy or sad with the action, it will now reply to the agent telling it that you did a bad job, and that's the reward RT. Okay, we will see how this applies in the application that we are working on, that is finance. All right, and as I said, our objective is to get a good policy, and the policy is like the map between what we are observing and what we are supposed to do. So when our brain of this is neural network, we call this deep reinforcement learning. Okay, and this is a short video of the first implementation of deep reinforcement learning. Let me see if I can play it out. Made by Google DeepMind. Okay, it's a company acquired from Oxford by Google. When they built this, it was acquired. Okay, so this is Atari block. You have played the game before, where you have these brick breakers that try to break the bricks. Okay, why this thing like this screen? Okay, let's leave it like this. So as you can see, this is now not doing well. Sometimes it stays in one place and the ball keeps falling. Now after 2 hours of training, and this is how you will see the improvement. And this keeps on improving now. This is, now you can see it doesn't allow the ball to fall easily. Okay, it follows along. Now this happens after 4 hours. So the funny thing is, after 4 hours, it tries to learn something that like grandmasters of this game normally do, and that is called tunneling. So it goes and creates a tunnel from the side and it throws the ball all the way up so that it keeps going on and on without even the brick holder or breaker even moving. So the agent was the thing, the table that moves around to catch the ball. So that means this table that is moving has two actions, right? Move left or right, move left or right, move left or right. Okay, so these are the actions that this agent can take: left, right, two options. So we want to make sure that based on the current position of the ball, the table moves to the right position. Okay, it could be saying move right, 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 right. Okay, depending on how you do it. So that's the idea. Okay, so we have come to the end of the introduction or overview of reinforcement learning agent. The next thing I would like to discuss is the framework I follow when I'm going to build a trading bot. So if you have a question, this is a good time to ask. Okay. And I believe no question, so I will move on. All right. So whenever we are building a trading strategy or trading bots, or when you look at trading in general, there are three things involved. First of all, there is the strategy, then you have the psychology, and then you have the management. The strategy involves the processes you follow to enter a trade or to get out of a trade. Okay. The psychology is your emotional state when making the trade, whereas the management is how you handle your money. Okay. So, how does algorithmic trading help us, or how does building trading bots help us? By developing algorithmic trading systems, what we are doing is we are trying to execute trades automatically. Okay, we are not going to be making trades manually. So our trades are going to be executed automatically. And we will be able to tell that system when to buy, how to buy, to what price. Okay, and the system will learn, for example, based on the instructions given, do this, do that, do this, do that, so that when this happens, this other thing should happen. So my own question here is, where does the AI comes in? All right. If I know a strategy that works well, for example, I start with Warren Buffett and he tells me this is a strategy and this is how it works. Okay, I can go and write a code that tries to do the same thing that Warren Buffett does, and it will be working continuously like Warren Buffett even after his passage. So the question is, why do we need machine learning if we can go and talk to somebody? Well, the real thing is, it is not going to be easy to have access to Warren Buffett, but it could be easier if you can get access to his historical data. You might maybe find, history of all the trades Warren Buffett has entered or the investments he had done before and the current investments he is holding. So when we curate all this data, we collect all this data, we have it, we can now train a machine learning model so that it will be able to figure out how, for example, Warren Buffett is making trades. What is the pattern? Okay. When does he make trade? And why does he make trade? Yeah, I think I saw a question in the chat. Okay, no questions. All right. Okay, so what are some of the benefits we get out of building a trading bot, or if we have a trading bot? First of all, there is the speed and efficiency. Of course, you cannot compete with a computer, right? You can't compete. All right, because this is its forte. Secondly, consistency and discipline. Okay, so when you are trading, for example, sometimes you might lack discipline, or sometimes you have planned for everything, but your psychology wins and you go and make huge mistakes. So when you have the bot, you don't have that issue, and it follows consistently the risk management that was defined. So there will be no issue in going and be playing around with the stop loss and take profit. You have the backtesting capabilities here. We try to test, the system with historical data. You do not have to wait for months to come to see how, to understand the efficacy of your system. Okay, so you can have this historical data to do that. You are a human being and you come up with a strategy. You have to wait, right? You have to sit on it, maybe on a paper trading account, keep trading until maybe after a week, a month, or 2 years before you come up with the decision whether your strategy works or not. But if you have the robot to do everything, then it can be able to do it all in milliseconds or microseconds sometimes. Okay. Scalability. If you are a human being, you can only monitor maybe one or two assets at a time, maybe three. You push yourself, you do four. But with the robots, you can have hundreds or 1,000 assets under monitoring or watch list. Okay. So now that we know this, the next thing is to talk about the tools which are going to be used. And whenever you are building anything, you need tools. And the tools we will require here include ChatGPT Plus. Okay, we have Google Colab, and then we have Python libraries. Finally, we have Alpaca API. Why do we need ChatGPT Plus? One, because we want to generate our codes without having to type it, if possible. So what do? We go and write to ChatGPT what we want to do, and we expect it to give us the code. Once we get this code, we will go to Google Colab, which is a free Python programming environment provided by Google. It's cloud-based. So you go to Google Colab and you'll be able to sign up for free. You don't have to pay. And once you have signed up, you can add your code there. You can run the code without any concern. Python libraries. As I said, Google Colab is Python based. Therefore, if you want to work with Google Colab, you need to get some libraries, and these are like adding, lots of things and making life a lot easier for you who is developing the trading bot, or you are developing anything, not just trading bot. If you are developing solutions in Python libraries will help you go a long way. You don't have to be building everything from scratch. I always say building, for example, could be considered, for example, as how you build a car. So if you have, let's say, your car design, you do not have to go and build every part of the car. Okay, you don't want to do that. You want situations where some parts are already readily available for you to go buy, attach, and assemble. All right. So this is similarly with Python. You have these libraries to allow you to carry out more complex computations without having to go deep down. All right. Alpaca API. So Alpaca is a brokerage account. It allows you to create an account that will help you, give you access to the real financial market. Okay, because we don't want to just build our codes in our local computer. We want to deploy this codes. So Alpaca provides an API, which is a bridge that can be established between our code and our Alpaca brokerage account. Okay, so we will see how to use this, okay, in the coming slides. So when building any algorithmic robot, there are three things involved. Okay, we have what we call the signal, we have the order types, and we have the risk management. So the signal is what tells us, okay, there is a trading opportunity. Let us go and utilize this trading opportunity. Okay, so once you know a trading opportunity, you will want to make a decision. Are you going to buy immediately, or are you going to wait? And that's the order type. So if you are going to buy immediately, okay, then you will also want to know how do you manage your money. If you are going to wait, then how long are you going to wait? All right. And waiting comes in two shapes. Are you waiting for the price to come down further so that you can buy and increase your margin? That is called limit order. Or are you waiting for the price to maybe start moving towards your prediction so that you get certainty and enhance predictive accuracy? All right. And then lastly, the risk management. So after you spot an opportunity, you decide when to buy. Once you have bought, you have to decide when to get out of the trade, which are the exits. Okay, here we have two or three of them. The first one being position sizing. Okay, so position sizing allows you to allocate a certain portion of your whole money to that particular trade. You don't want to put 100% of your money, all of it, on just one trade. You want to have maybe 10, 5, 2% is the recommended amount, okay, in that one trade. Okay, so take profit will help you decide what point or what level should I get out of this trade, no matter how profitable the trade is looking like. If the trade is looking like it's gonna break everything, it's gonna break all barriers, it's going to the moon, you don't care. You already indicated that once it reaches a level, You want to sell, you are happy with doing that. That's the take profit. So you have to decide what level is that. Stop loss means you want to stop your losses. You don't want to blow up the whole account. So if let's say we have put, let's say, 1,000 or $2,000 in our account, and then we went into buying, okay, we buy stuff, we bought it, and then the things we bought, we wait, and the price start to crash down. If we don't have stop loss, we're going to lose all cents, all of our money in just one trade. Okay, that's why if you have a stop loss, maybe once a certain percentage of the amount is lost, okay, once you lose a certain amount, then you can say, okay, I'm happy with this small loss, I'm going to go without having to stay and lose more of my money. Okay, so what I'm going to show you now is how do you implement these three things: signal, order type, and risk management, and how reinforcement learning is going to help. Where is it going to help? All right, so let's start with the signal. How do we spot a trading opportunity? Are we the ones who are going to do that, or are we going to delegate this job to the AI? And that's exactly what I'm going to do. The part of spotting a trading opportunity is now going to be handled completely by the AI. Okay, he will be the one to handle it. He will be the one to use historical data to learn patterns. After he learns patterns from history, then he will be able to tell when is it right to buy or sell a particular stock. All right. So okay, so let's look at this. Normally, when you are doing reinforcement learning, the first thing you start with is what we call MDP formulation, the Markov decision process formulation. Okay, that is, you have to define what is your agent. Remember, the agent is the thing that works. Okay, so this is the, you can call him the trader. Okay, this is the guy that will trade. Okay, is the trader, and his brain is going to be a neural network based brain, neural networks. Okay, so there are many of them there, but the one that I will use is going to be called DQN. Okay, Deep Q network. Deep Q network. This is the type of agent I'm going to use. Deep Q network. All right. The environment. This is where the agent is going to be interacting with. This is like the playing field of the agent. In our case, this is the financial market, right? So it's going to be the financial market. Okay. The environment is the financial market. Okay. So this financial market will give some signal, some information upon which the agent is going to decide what to do. And those are called the states. Okay. So in my case, these states are this RSI, okay, relative strength, okay, indicator. We have MACD, we have ATR. Okay. Let's say these three are my state. So the financial market will be given RSI, from historical data. When you look at any, let's say, any asset, you can take, let's say, Tesla, for example. If you go and you will see three different values, you will have O, you will have H, you will have LCV. The open price of Tesla, the high price, the low price of the day, or the whatever time frame you are using, the closing price, and then the volume that was traded within that time. Okay, so with this you can be able to compute these technical indicators: RSI, MACD, ATR. You will have maybe simple moving average, you will have exponential moving average, all of this. So based on this, now if I know what is the RSI, for those who attended our second session where we use RSI algorithm, for example, RSI based trading strategy, we said if RSI is above 70, that means that stock or that asset is what, overbought. So we are going to go short, right? Go short. If RSI is below 30, we are going to go long. We are going to buy, because that means that asset is oversold. That was our own I would say, traditional or manual trading strategy. We were the ones who were saying, okay, use RSI as an indicator and look at the value of the RSI at this current time step, okay? Based on the value of RSI, compare it with this value, 70 and 30 thresholds. And based on this, decide to go short or go long. That was what we did before. Now we are not doing that. We are not just looking at RSI alone. We provide RSI, we provide MACD, we provide ATR, we provide SME, EMA. All of these are generated from the financial market, and we feed this to the agent. Okay? Let him be the one to figure out these things. We are not going to be giving him these values. Let him be the one to figure it out. And he is going to figure things out by trial and error. You will not know that 70-30 is a good value for RSI. He will be able to figure it out on his own without us. Okay? So we give it this, and he will have 3 actions. So, given these current values of this, he will decide, okay, should I go short? Should I go long? Or should I hold? So he has 3 options to make. Okay? He will make this one of these 3 options. He will decide, okay, RSI is less than 30. Let me go long. Oh no, RSI is above 70, is greater than 70. Let me go short. No, RSI is in between 30 and 70. I'm going to hold. Assuming I am the agent, maybe. Who knows how he is going to figure it out? Anyways, he is going to figure it out by trial and error. And that's what we want to get. So once he decides an action 80, okay, he will pick one of these 3. He will pick one of these 3 and he will put this action, he will execute this action on the financial market. Okay, so we will see, are we happy or not? How do we know whether the action is a good one or not? We look at our account balance. So our reward is going to be the account balance. If our action is a good action, that is, we made the right choice of buying, or we made the right choice of going short, or we made the right choice of holding, nothing happened, then our account balance will reflect that. It will reflect how good our decision was. So this is the reward function. Okay, so this is how I formulated the whole problem, and I'm going to talk to ChatGPT, and we're going to have these conversations, me and him, and ChatGPT will be able to give me the code that I will be able to run and develop this. Okay, I hope this is clear, because this is the most important part, to understand that this is how all these things come into play. All right, so this is how I will get the signal. Okay, now to the logic. How is my logic going to be? Okay, so the logic is going to be like this. When I start, let's say this is the first time. So if my agent says go long, okay, or picks, let me use this word, picks go long action, okay, meaning that he has supported that there is an opportunity if I go long, okay, and I am not in any position, okay, meaning this is the first time I am buying this particular asset, Tesla. I have not bought it before, and my agent is telling me go long on Tesla. Tesla looks good, let's go long. Okay, then I'm going to buy. I will buy or I will go long. Okay, the opposite is the case, okay, for going short. So if I am not in any position, okay, and my agent tells me, oh man, Tesla is not looking good, you're going to go short. You know, people are not happy with Tesla, so I will go short. Okay, so I will go short. All right, so these are 2 situations. The third situation is I'm already in position, meaning I already bought Tesla. I got one stock of Tesla. At the end of the time step, my TPO stop loss has not been triggered. I'm still in the trade. And then my agent is still telling me, buy Tesla, buy Tesla. Since I already bought it, I'm not going to buy again. So if I'm already in position, and the agent tells me to take the same stance, okay? And the agent tells me to take the same stance to make the same decision again, I will not do that, okay? Because that will be kind of duplicate. So I will just maintain my position, okay? However, if he tells me to take the opposite action, I bought Tesla based on his recommendation in the previous time frame. Now, in the new time frame, the agent tells me, sell Tesla. Okay, I will sit and say, all right. That means the agent has reversed his decision, meaning things are not looking good anymore. Before they were looking good, so I was buying. Now the agent has spotted that things are not looking good. So let's sell and go out, right? So if I've got a contrary action, I sell and go. Okay, I sell and or I exit the trade. Okay, so these are 1, 2, 3, 4 scenarios. The fifth scenario is like saying, okay, if my agent says hold, okay, if it is hold, then I am not going to go long or short. I will just look at it. Do I have trades? If I have trades, I stay, I maintain them. If I have no trades, I'm not going to do anything. Okay, that means hold. No trades, nothing. I have trades, maintain them. As simple as that. And of course, once my TP or stop loss is triggered, I'm going to get out of the trade. So this is my trading logic. I will explain all this to ChatGPT. Okay, moving on. Order type. So as I said, once this agent supports an opportunity, is the agent going to buy immediately or is it going to hold on? Yeah, as I said, agent buy immediately. So market order. Okay. So it is going to be a market order. So this is the order type I'm going to use. For the case of risk management, I am going to use a simple approach. First of all, I will say I don't want to invest more than 2%, okay, for the position sizing. So no matter how good an opportunity is, I'm not going to go more than 2%. So if I have, for example, 10,000 as my account balance, the maximum I'm willing to invest is what, $200. So I don't want to lose more than $200 per trade. And if that is the case, my risk to reward ratio too, I set it to be minimum 1:2. Okay, meaning if I'm willing to lose the 200, then I am hoping to get what, 400 if I'm right. Okay, for example, let's say Tesla is 1,000, then I put this. So if I am going to lose what, 200, okay, meaning my money is going to be 800 if that happens to be the case and the agent was wrong, okay, and I'm willing to get all the way, sorry, yeah, it's 10,800, yeah, or 9,800, sorry, plus 400, that is the profit I'm hoping to get, meaning that my account balance after this is going to be 10,400, okay, 10,400. So this is my plan, okay. Therefore, my stop loss is going to be 200 below my entry point, right? So if I entered, for example, when Tesla is at what, 1,000, so it's gonna be 200 below. So it's gonna be, my stop loss is going to be at what, 800. If I entered, let's say at Tesla when Tesla is 600, my stop loss is going to be 600 minus 200 is going to be 400. And then my take profit will be at 400 above, $400 above or below the entry, depending whether I'm going long or going short. Okay. So if Tesla is 100 by the time I purchase it, I'm hoping to sell it when it reaches 1,400. Okay. If Tesla was, let's say, 500 by the time I bought it, So I'm hoping once it reaches 900, I will sell and take my 400 naira dollar profit. So this is my RRR, the risk reward ratio. So with this, I am able to maintain and manage my account. And I will explain all this to ChatGPT and it will give me the corresponding code. And this is the framework we are going to follow. First of all, we will set up the environment. Once the environment is set up, we will discuss the strategy with ChatGPT, which it will give us. Then we will follow the reinforcement learning process. Once everything is set, we will train the agent. The agent will start learning using trial and error until when it figures out how things work. Then we're going to test the strategy. If we backtest maybe up in the past 1 year, 10 years, was this good? This agent was it good? We will see. How will we tell whether it is good? Is from looking at our account balance currently. You know, if our current balance has grown over the years, then we know okay, our agent has really learned some few things. So let's see how it works in the real market. And that's where we do the connection and then we automate so that it keeps working automatically. Okay. So before I move into showing you how to do this in okay in the coding environment and chat GPT and everything else, for those who require the resources, you can get resources of this workshop. The video, all videos are recorded. Okay, I record all sessions and we put everything on our YouTube channel. So if you go to YouTube and you check ASAT Academy, ASAT, okay, Academy, you will be able to find the recordings of the previous workshops which were held the previous weeks. All right. And we have our learning portal. You can go to our learning portal. You will also be able to get resources as well as download the resources. So for those who want the learning portal, the code is in the chat. So that is the link. Okay, you can follow that link and you'll be able to access the recorded sessions as well as download the resources for free. Okay, and we have also some AI powered features in the learning portal to help uh, those who are trying to learn and streamline their learning process, make it more easier for them to have access to the right knowledge. All right, and for those who are interested in going deep into AI and stuff like that, okay, if you are interested in that, you want to go deep into AI and stuff like that, please, you can reach out to me. I will give you the code for that. Okay, I think I have the code. So just in the chat, you can write one on one. I will send you the code, a link for you to book a meeting. And we will have a free 30 minutes call, me and you. One on one is free. You don't pay for it. I get to understand what are your requirements and I get to maybe give you some hints and suggestions. And if you want to, for example, learn AI, how to build AI systems, how to implement AI systems in different sectors, ranging from finance, communications, whatever, you can reach out to me. Okay. We have workshops coming along also. We have, this is the last workshop of this week, and we will have others coming the week after. Okay. Yeah. So the week after this, we will have workshops on natural language processing, where you will be able to see how we will build training bots that will be able to read and write. Okay. All right. So let's go into building our robots. Okay. All right. So we have our system here. I already got almost everything ready for the sake of time. Okay. So the first thing I did was to install libraries, which is the first step, environment setup, and these are the codes. Just execute this line and your environment is going to be, yeah. So all libraries are going to be installed accordingly. Okay. All right. So this is done. So the next thing is to test connection with Alpaca. And what I did was to talk to ChatGPT. I told it, okay, I want to build a trading bot with Facebook stock. I want to use Alpaca API to connect to the market. I've installed all necessary library requirements. I'm using a paper trading account to test my strategies. And to test the connection, I want to start by executing a market order on Amazon. Let the trade run for 10 seconds. Okay, so give me this code, copied it, I pasted it here. Let's check our Alpaca. Okay, so yep. All right, so let's see. This one is going to try to buy Amazon. Okay, so let's place an order. Amazon, new order here has been placed. Okay, after 10 seconds, it will cancel this order. Cancelled. Okay, yeah, cancelled. Just changed it a few seconds ago. All right, so you have been able to see the connection. All right, so the next thing I want to do is to move to the next step. So I told it my strategy, which is the next step. I explained everything. My objective is to build a reinforcement learning based trading bot. All right, and for going long, I am going to use the DDQN agent to generate when the agent picks the buy action. And using a DDQN agent is generated when the agent picks the sell action. So the agent is the one to tell me buy or sell, not the one who will determine this. All this is now the job of the agent. After each candlestick, the agent will pick an action based on the observations. So we will know the observations are the RSI, those technical indicators. If the prediction is to go long, so if the agent says go long, which means buy, okay, and I'm not holding any position, I didn't buy anything, I'm going to enter a long position. I will set my take profit according to risk management rules. I will set my stop loss according to also risk management rules, which I explained. If the prediction is to go short, and currently I'm holding no position, I'm going to enter a short position. I will set my TP according to the risk management rules and also the stop loss accordingly. If the action is the same as the current position, that is to avoid duplicate orders or hold. All right, so I want to hold or I don't want to have duplicate orders because it is telling me to buy after I'm already in position. Then I'm going to maintain my current position. I will just adjust everything accordingly. However, this is when I will exit. The first exit is to what? If the prediction is opposite of the current position. So I was buying Tesla, but then after the end of the time, now the agent is saying, you know what, sell Tesla. So this indicates trend reversal, exit the trade. So now I'm done with the logic. The next thing is what? The order. When am I buying? I want to buy immediately. So market order. Risk management, I told it everything that I don't want to risk more than 2%. My stop loss and everything, minimum 1 to 2, okay, for the risk reward ratio. The next step is the reinforcement learning process. Let me know if you understand this before you move to the next step. And it explains everything accordingly. and I know it is correct, then we went to the next step, which is the reinforcement learning. I told it to get data within Y-Finance library, 1 year data, get these values, okay, and use TA library to get them. After you get everything, decide whether to buy, sell, or hold. The reward should be the current account balance, okay. The reward should be the current account balance. Actions should be to buy, sell, or hold, and so on. So the DDPN agent is going to use the OpenAI baselines, and it will initiate this, and we would like to plot some things. Okay. So I got all these codes, got everything, and as you can see, this is it. Trading environment. This is it here. So I can run this part. Okay. All right. So I was done. Yeah. So a few things I got it to make some corrections. Sorry. Yeah, which I added here. So that okay. So the next thing was for me to do back testing, right? Okay, there is training. So we want to train. Okay, we have defined everything. Now we want to train. And this is it here. It will start training. I will start it and give me the code to train. Yeah. So you see model.learn. This is how it is going to learn, which is here model.learn. It will start learning and training. It has started. Okay. So although if you understand how reinforcement learning works, here it terminated early after just 4 episodes. Here it went all the way to 8 episodes. So as you can see, it keeps on increasing, keeps on improving. Have the exploration rates and what have you. So this is my reward. It keeps on increasing this time, keeps on learning. Okay. Still learning. Okay, I think it's done. Okay, so it's finished. Let's see the last one, which is this one. Okay. All right. So we are done with this. The next is to backtest. Okay, to test it in the previous year. Give me the code backtest environment, which is this backtesting. Okay, so I will run this backtesting code. Okay, so many positions, long, long, short, short, nothing. Some I don't do anything. Okay, at the end, I ended up with 10,400. Remember, I started with 10,000. Now it has been able to make $400 at profit because the current account balance is 10,400. Okay, so we are happy. The last steps are to connect to the market and automate the whole process. And these are the codes to do that, which is provided for me. It gave me a skeleton first. Then I told it to fill out the skeleton, which is something it did for me. Whenever you get an error, you just tell it, I've got an error, to be able to help out with that. Okay, so these are the codes it gave me. Fetch real time, execute trade, and main trade function. Then the last one in the code to complete the code. So fetch real time, execute trade, the main trade function, and then the last one is to complete the trading bot code. Okay, so this is it. It is going to run and run and run until when it is done running. Okay, so after 1 hour it will make a trade. Okay, after sleeping for 1 hour it will make a trade. Then it will see if it is going to buy or sell. Then it will check again after an hour, and that's how it is going to continue doing that. All right, so yeah, so we've come to the end of this workshop. As I said, if you have time to book a call, can do that within this link, and I will be happy to be of assistance. If you have questions, you can ask.